Unit 4, Day 5, Combining Random Normal Variables. Any linear combination of normally distributed random variables is also normally distributed. For example, if x and y are normally distributed, then x plus y, x minus y, or even 2x plus 3y are also normally distributed. And when you use the formulas we've been using so far, if we're adding or subtracting two variables, so x plus or minus y, and the new mean would be the mean of x plus or minus the mean of y, depending on what you were doing. And the standard deviation of x plus or minus y would be the square root of the variance of x plus the variance of y. Or if you're multiplying, the mean of some constant times x, so ax, is just a times the mean of x. And for the standard deviation of some constant times x, if that constant is a, that's the absolute value of a times the standard deviation of x. And we could also use them in combination. Let's look at an example. If men's weights in pounds are normally distributed with a mean of 197 and a standard deviation of 4, and women's weights in pounds are normally distributed with a mean of 165 and a standard deviation of 43, and a man and woman are selected at random, what is the probability that the sum of their weights is at least 300 pounds? And it says, what assumptions must you make to do this problem? First off, the assumptions are that men's weights and women's weights are related, that they're independent. So picking a heavy man won't make it more likely that you pick a heavy woman when you randomly select them. And then you need to define your variables. So we'll start with the men. So x sub m is the men's weights in pounds, and x sub m is approximately normally distributed with a mean of 197, a standard deviation of 47, and I even drew the curve so you could see kind of how it looks. And then we would do the women. X sub w would be the women's weights, and then you can see the mean there and the standard deviation in the curve. And then we have to combine them. So we combine them to be the sum of the men and women's weights, remembering that sum means plus, so we're really adding the two. And we need to make a new curve and then look at the question. So the new thing would be we want to add the men and women's weights, so we use our formula and get a new average of 362 pounds, and we put that on our picture. And for the standard deviation, we use the formula with the square root because we're adding, and we get a new standard deviation of 63.7 pounds. So we use that to fill in our picture so we can see what's going on. Now what we really want is we want the probability that the man plus the woman is greater than 300. So we go ahead and draw in our 300 mark and shade the correct area. And then using our calculator, not forgetting to label, we did norm CDF from 300 to 1,000 with a mean of 362 and a standard deviation of 63.7. And we get that we have an 83.5% chance of, when you pick a man and a woman, together they weigh more than 300 pounds. Okay, so that's pretty straightforward with the add and subtract. What about the probability that the woman is heavier than the man? So now we're looking at the difference. Well then, in that case, we'd want to subtract. So let's do the women first. Same thing. We name our variation, woman minus man. And we think about what the mean's going to be. Well, based off of our formulas up above, we'd subtract them. So the mean of 165 for the woman minus the mean of 197 for the man would be a negative 32. And that would be because women tend to be smaller than the men. So you're doing a small number minus a large number. So you get a negative difference. Find our standard deviations. Remember, when we are doing standard deviations, even though we subtract, we add. And we get the same standard deviation that we did before. And then we draw our picture and think about it. If the woman is heavier than the man, then in this case, because the woman is first, our difference should be greater than 0. So that's what we look for. And the probability of that happening is 30.8%. we could do the same thing the other direction. So when they ask for the difference and they don't specifically say that it has to be the woman first, you could find the answer either way. Although I would usually do it, if it said woman is heavier than man, I'd put woman first. But some people don't like having a negative mean, and so then they could put the man first. So here's the deal. X is now the difference of the man minus the woman. Okay, we find our average, or our average difference, and this time it's a positive 32 pounds, which tends to make people happier. So if you always like to have a positive something, fine. And then in this case, for the woman to be heavier than the man, I already did the standard deviation, it's the same. For the woman to be heavier than the man, the difference would have to be less than 0, right? Because she'd be the big one. So small number minus big number would be less than 0. And you do it and you would get the same answer, 30.8%. So basically you define the new distribution, then you find the new mean using our formula, the new standard deviation using our formulas, draw your curve, shade in what we're asking for. Using the calculator, don't forget to show and label your work, you would get your answer. Let's try another one. If you were to select 3 men at random, what is the probability that the sum, so we're going to add, of their weights is at most 500 pounds? So what we would do first, again, is define the new distribution. So the x is men plus men plus men, which would be the sum of the weights of the 3 men. Okay, so mu of man plus man plus man is the mu of the man plus the mu of the man plus the mu of the, I should say, men. Okay, which would be, let's see, the average man weighs 197. That'd be 197 plus 197 plus 197. And the new standard deviation of man plus man plus man is the square root of the variance. And let's see, our variance was 47. Or our standard deviation was 47, so 47 squared plus 47 squared plus 47 squared. And we have a new standard deviation of about 81.4 pounds. And then again, now we ask the question, we want the probability that this sum is at most 500 pounds. So probability, the x of m plus m plus m, is at most, that means no more, than 500 pounds. That's what we're looking for. Draw our picture. Add and subtract the standard deviations, so you get a picture of what your distribution looks like, and then go ahead and fill it in. So we want them to be no more than 500 pounds, so that'd be here. So a little less than 1 standard deviation below the mean, so a z-score of -1 something if you weren't going to use a calculator. And so this is 500. And then we do have to show our work. Norm CDF from -infinity to 500, new mean, and new standard deviation. And remember, lower bound, upper bound, and that would give us, and if we put that in our calculator, we would get about 0.1317, so about 0.132, or 13.2% chance that if we picked 2 people from this population, 3 people from the men's population and added up their weights, that they would weigh 500 pounds or less. Let's try another example. Suppose that the weight of a candy bar has a mean of 4 ounces with a standard deviation of 0.15. Also, the king size version of the candy bar has a weight of 7.5 ounces with a standard deviation of 4 ounces. Assuming both distributions are approximately normal, we talked about that, what is the probability that a randomly selected king size bar weighs more than 2 randomly selected regular bars? So again, list what K and R. K is for king size, R is for regular. And then we've got our mean and our standard deviation. So we've labeled everything and defined everything. And now we have to look at what we're asking. And we want the probability that a king-size candy bar weighs more than 2 randomly selected bars. So what we really want is king size being greater than 2 randomly selected bars. That is not 2R. That would be 1 bar twice as big, which would probably end up being about a king size or maybe bigger. Instead, that's a regular plus a regular. Okay, and if you subtracted R from both sides, you'd get king size bar minus R needs to be greater than 0. So we want the probability of a king size candy bar minus a regular candy bar minus a regular candy bar being greater than 0. And that's our question. So now we need to find the new distribution. So the mean of king size minus regular is going to be 7.5 minus 4 minus 4, or an average difference of 0.5 ounces. And the standard deviation of king size minus regular is the square root of the sum of the variances. Again, remember, difference doesn't change it. Send it 100 times. So we've got 0.4 squared plus 0.15 squared plus 0.15 squared, which is equal to 0.45 ounces. So we draw our picture with an average of 0.5, and we could fill these in. So this would be negative 0.05, and what we want is this sum to be greater than 0. It's going to be about here. That's going to be your 0, and bigger than that. So your standard deviation, a little less than 1 standard deviation. So a z-score of like 0.9 or something like that approximately. And we would go ahead and put that in our calculator. And I'm going to leave off the calculator writing for time's sake, but you would get a probability of approximately, so anyway, your probability would be approximately 86%. And I just put this in my calculator and looked at it and saw my 86% does not match my picture. And I was having a little bit of a hard time with that. So I started looking at it and realized that I had written down my mean incorrectly. It's actually a negative 0.5. So that's going to change where my shaded area is. And this would be negative 0.05. So I had that right. And my 0 would actually be a little here. And I'm going to put the new mean in, and we should get a better standard deviation. So when I put the new one in the calculator, instead of getting 86%, I actually got about 0.133, or approximately 13.3%, which matches my picture better. And the only difference was that I had lost this little negative sign. Again, that's another benefit to drawing the picture, is I realized that 86% didn't match my picture at all, and that I'd made a slight error. So the probability of grabbing a random king size bar and 2 randomly selected regular bars, and the difference of the king size minus the random being greater than 0 is about 13.3%. We will, in class, do this one, and I will show you how to do it with the calculator. Don't start the next homework, but come prepared. Actually, do start the next homework. We decided that. And come prepared to class with questions.